Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Policy Gradient Methods. When AI learns by adjusting its habits. Reinforce an intro to Actor-Critic. Imagine you're building an AI. You want it to learn how to play a complex game, drive a car, or even manage a factory. How does it learn the best way to act? Instead of memorizing good moves, what if it learned a general strategy or habit that helps it make decisions directly? That's what policy gradient methods are all about, teaching AI to adjust its decision-making habits to get better results. It's a powerful way for AI to learn even in really complicated situations, especially when actions are complex or continuous. Remember reinforcement learning, RL. It's like training a pet. The AI, our agent, tries things out in an environment. The world it's in gets rewards, good points, or penalties, bad points, and tries to maximize those rewards over time. It makes an action, like pressing a button, observes the state, what the world looks like now, and learns. In previous methods, AI might try to figure out the value of each action in a given state. But today, we're going a different route, focusing directly on the strategy itself. Imagine you're building a robot arm. It has to pick up an object, and its actions aren't just left or right, but precise angles and forces. Continuous values. Or, what if your AI's strategy is so complex that trying to calculate the value of every single possible action becomes impossible? This is where traditional value-based RL methods, like Q-learning, which tries to estimate the Q value or goodness of each action, start to struggle. We need a way for the AI to learn its strategy directly, without worrying about calculating individual action values. Instead of calculating values, let's give our AI a policy. Think of the policy as the AI's personal strategy book or its set of habits. When it sees a certain situation, a state, its policy tells it what action to take or asterisk the probability of taking different actions. From a developer's perspective, this policy is often represented by a neural network. You feed the current state into the network, and it directly outputs the action the AI should take. It's like coding the AI's decision-making logic directly into its brain. So, we have our AI with a policy. Its strategy network. How does it learn? Policy gradient methods are all about directly adjusting the parameters, weights and biases of this policy network. The idea is simple. If an action leads to a good outcome, high reward, we want to slightly adjust the policy so that action is more likely to be chosen in similar situations next time. If an action leads to a bad outcome, we make it less likely. It's like subtly tweaking the knobs on a machine to get better performance based on the results you observe. Reinforce is one of the simplest and foundational policy gradient algorithms. Here's how it works. 1. The AI uses its current policy to play through an entire episode. Like one full game, it takes actions, gets rewards, and records everything. 2. Once the episode is over, it looks back at the total reward it received. 3. Then, it updates its policy. It makes actions that led to high overall rewards more probable for the states they were taken in, and actions leading to low rewards less probable. Think of it as a coach watching a whole game. Then after the game, telling the player, "That move in the third quarter was great. Try to do it more often." Single quote. While reinforce is cool, waiting for the entire game to finish before getting feedback can be slow and inefficient, especially for long games. What if the AI could get feedback during the game? For each move? This is where actor-critic methods come in. The actor This is our policy network. The one that decides what actions to take. The player. Asterisk the critic. This is asterisk another neural network. Its job isn't to take actions, but to asterisk evaluate how good a given state is, or how good a specific action taken by the actor is. Right then and there, think of it as having a coach. The critic, giving real-time feedback to the player. The actor, during the game, rather than just after it ends. This makes learning much faster and more stable. In Actor-Critic, the actor, our policy, tries an action. The critic then immediately tells the actor, "Hey, that was a pretty good move," or maybe not so great. This real-time feedback helps the actor adjust its strategy much faster and more efficiently than waiting for the end of a long episode. The actor learns to take better actions, and the critic learns to give better advice. They learn together, making the AI's habits, its policy, much smarter, much faster. This dual network approach makes actor-critic methods very powerful for complex real-world problems, like robotics or autonomous navigation. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.